Okay, we are going to find the integral of 2x squared e to the 2x dx using integration by parts. The first thing to remember is what is the formula for integration by parts? And so I like this little table here because it tells us the formula, and then it helps us choose u. So the integral of anything multiplied by something, so u dv, is going to be uv minus the integral of v du. So we need to first figure out what are we going to say is u and what are we going to say is dv. And this is how we choose. So we are going to choose in this order. The u, you should choose a logarithmic function first, then an inverse, then an algebraic, then a trig, then an exponential. In this problem, we have an algebraic function and an exponential function. Algebraic comes first. Therefore, we should label our u as 2x squared, making our dv e to the 2x. So now we know what our u and our dv are. We need to figure out what's v and what's du. I like to use this cool little table. And in this table, I'm going to put my u here, and then my du goes here, my dv goes here, and my v goes here. So we have said that u is 2x squared, meaning du would have to be 4x dx. Our v is e to the 2x dx, making our v, the integral of e to the 2x, is 1/2 e to the 2x. Now we have all the information that we need to do this. So so u times v is going to go this direction. U is 2x squared, and v is 1/2 e to the 2x. When I multiply those together, 2 times 1/2 is just 1. I'm going to get x squared e to the 2x. Then I need my v times my du, so I'll go this way. So v is 1/2 e to the 2x. Du is 4x dx. Well, 4 times 1/2 is 2, so I'm going to have 2x e to the 2x dx. We are not done with our integration by parts until we've dealt with all of our integral symbols. And that means that we now need to integrate this piece here. And after we've integrated that piece there, then we're done. But I noticed something. I noticed that I have a u and a dv again, because I have two products. I guess I have a set of products, 2x and e to the 2x. Because I labeled the 2x squared my u before, I'm going to label the 2x my u this time so that I'm consistent. And then I'm going to label this my dv. So I'll go ahead and I will make my box again. And u goes in the left upper corner, which is 2x, which makes du 2 dx. My dv is e to the 2x, which is going to make my v 1/2 e to the 2x. So I'm going to carry this piece down with me. So when I carry that piece down with me, I have x squared e to the 2x minus, and now I'm going to do the same process that I did before. 2 times 1/2, or 2x times 1/2 e to the 2x. Well, 2 times 1/2 is 1. So I'm going to get x e to the 2x minus the integral, and now I have to go this direction. Well, 1/2 times 2 is just 1, so I have e to the 2x dx. I am not done until I have dealt with the integration piece of it, but this integral is easy because I don't have a product anymore. And we've actually taken this integral twice before because it was here and it was here. So I'm going to clean up my signs a little bit. So this is going to turn into x squared e to the 2x minus x e to the 2x. I have a minus that's getting distributed in, so this becomes a plus. And the integral of this is 1/2 e to the 2x plus c. This is one acceptable answer. However, we could simplify this a little bit. We could factor out an e to the 2x. And if I factor out an e to the 2x, I would put that out front. And in this term, I'd be left with x squared. In this term, I'd be left with minus x. And in this term, I'd be left with minus 1/2. Make sure you add that plus c. This is another acceptable answer. Either one of these answers is okay. This one helps me see, if I were to try to find zeros, this one would help me see that. And that would be the benefit of doing it that way over the other way.